Good morning, good afternoon, everybody. Thank you for joining our webinar. Today, I'm going to present an overview of ICAO provisions related to flight inspections. In this slide, you can see the list of standard navigational aids as mentioned in Annex 10, Volume 1. They are well known, but I'm going just to list them to refresh our memory. The first one is in the Instrument Landing System, ILS, which includes localizer and the glide path. The second one, which is the Microwave Landing System, MLS. And in the mid-region, there are no country implemented MLS in any of our countries. Then we have the Global Navigation Satellite System, GNSS. As we know that the standard and recommended practices for GNSS are in place with the augmentation to support PPN operation or implementation. Then we have the VHF, Omnidirectional Radio Range, VOR, the Non-Directional Radio Beacon, NDB. In the mid-region, we agreed that NDB should be rationalized based on need and equipage. Furthermore, Middenberg 12 meeting, which is the Berg in the mid-region, urged the state to plan for a complete decommissioning by 2012. Then we have the distance measuring equipment, DME, and the VHF markers. In Annex 10, Volume 1, we can find the standard requirement for ground and flight testing for all radio navigation types mentioned in the previous slide and engaged in international air navigation shall be the subject of periodic ground and flight tests. The guidance on the ground and flight test, including periodicity of the testing, can be found in ICAO Doc 8071, the manual on radio, the manual on testing of radio navigation aids. As we know, both ground and flight testing are required. But what are the differences between the two tests? You can see in the slide. The ground test carried by a specialist on the ground using appropriate equipment. It's also less costly and more appropriate for a quick evaluation of facility performance. It can be carried out more frequently, and also it can be used as indicators to determine when a flight test is required. While flight tests carried out by flight inspection crew, it's required to examine the signal in space as received at the aircraft after being influenced by external factors such as terrain, site conditions, etc. So flight test is in-flight evaluation of radiated signal. The flight inspection services can be provided by several options. The first one is a state flight inspection unit, or by obtaining this service from other states, or it can be done by outsource this service to commercial companies. Tomorrow we will receive a presentation from 4 states as Abbas display during the opening remark. We will receive from 4 states, 2 of them are using their flight inspection unit or companies, and the other 2 outsource this service to commercial companies. In this slide, you can see ICAO main provisions related to flight inspection. As we said, the SARPs for flight inspection can be found in Annex 10, Volume 1. So what we need to comply with, or what is said need to comply with, is Annex 10. Also for guidance material, you can find it in ICAO document 8071. And this document includes 3 volumes. This document is manual in testing of radio navigation aids. The first volume is about testing of a ground-based radio navigation system. The second volume is about testing of satellite-based radio navigation system. We will receive a presentation on update of these 2 volumes in the coming sessions. Also for volume 3 of document 8071 is about testing of surveillance radar system. Another document, which is 9924, It's about aeronautical surveillance manual. And this document includes provisions for ADSB and MLAT or multilateration testing. This MLAT and ADSB testing is out of scope of this webinar. Just I put it here as a reference for modern surveillance system testing. Last document, which is 9906, it's about the quality assurance manual for flight procedure design. We will receive also presentation on it in the last session of today. So as we mentioned, the SARPs related to flight inspection can be found in Annex 10, Volume 1. We can find the general provision and technical specification for radio navigation aids. ICAO document 8071 provides general guidance on testing and inspection carried out to meet SARPs in Annex 10. It includes practices existing in a number of states with considerable experience in operation and maintenance of navigational aids. So document 8071 is guidance material only, do not have the status of SARPs like the Annex 10. In this slide, it talks about ICAO USOP CMA, which stands for Universal Safety Oversight Audit Program Continuous Monitoring Approach. It's ICAO audit program, it's well known also. USOP audits focus on state capability in providing safety oversight by assessing whether states has effectively implemented the critical elements of safety oversight system. So in USOP ANS part, there are two protocol questions related to radio navigation aids flight inspections. As you can see in the slide, this is the first one, protocol question number 7.393, which is about ensuring that requirement for flight inspection are established and periodical flight inspection are provided for radio navigation aids. If you look at ICAO reference, you can see that the reference used is Annex 10 and document 8071 in addition to other standard documents. And this one also is related to critical element number 7, which is surveillance obligation. This is one of the 8 critical elements of USOP CMA program. In this one, you can see this is the second protocol question about the flight inspection, which is about ensuring that flight inspection of IFP or instrument flight procedure, including obstacles check, are carried out. That was my introductory presentation. Thank you all for your attention. Over to you, Abbas.
Thank you, Mona, for the brief overview of the ICAO provisions on the NAV flight inspection and the requirements by ICAO provisions, as well as the USOP CMA program. Next presentation would be provided on the ICAO Doc 8071 Volume 1 by Mr. Gerhard Berz from Eurocontrol. He is a senior expert of navigation systems. And after this presentation, we will have a short Q&A. So please do not hesitate to provide your questions related to the first two presentations, and we can have the opportunity to discuss them during the Q&A. Gerhard, may you please share your screen, open your camera, and turn on your video, please. And the floor is yours.
Okay. Hello, everyone. Can you hear me?
Yes, loud and clear.
Okay, so this presentation is an adaptation of something that I did not get to present 2 years ago, but some of my colleagues presented. One of my colleagues presented at the Flight Inspection Symposium. And so I reshuffled these slides a little bit to give you some different emphasis, but basically this is about the update of volume 1, which continues to be a very important document. So one thing you might notice that there's a beautiful picture of an ILS localizer on the volume 1, and that too is thanks to the good cooperation that we have received by providing royalty-free and copyright-free imagery of actually the real systems that we are talking about in the document. So personally, I'm proud to have a proper localizer picture on the front cover of Doc 871 Volume 1. I'll go over a little bit more, adding on to Muna's presentation on the Volume 1 in context of other documents. What was the motivation for the update? What is its status? That too was covered already a little bit. What are some of our struggles in writing the words? In our so I'm the rapporteur of the ICAO NAV systems panel conventional navigation and testing working group. So sometimes we struggle with finding the right words, and then I go also a bit give some chapter by chapter examples. So the big reason to update the document was really Amendment 84 to Annex 10 in 2008. That was a very general review to just delete obsolete and clarify ambiguous provisions based on feedback received over the years. There's one small part of Amendment 84 which was rejected, which was the ILS critical and sensitive area material. That finally was revised and made its way into Annex 10 in Amendment 91, applicable November 2018. What we've written in Doc 8071, I think, is largely consistent with that, even though it wasn't really impacted much because the critical and sensitive area guidance is really in the green pages of Annex 10. The main big editorial change is to move out of all the flight validation material from 8071 to Doc 9906, as was already shared as one of the related documents. And the main two volumes remain the two volumes 1 and 2 on ground and space based. Those will be kept 2 volumes, and the new 5th edition was published in summer 2018 in English, and then I'm not sure what the status of the other languages is. Briefly touch on the neighbors. The Volume 2 update has a bit of delay because there was quite a bit of effort in the NAV systems panel to update the SARPs. So GNSS SARPs were initially introduced in 2001, and this is the second major SARPs update, introducing GPS new frequency, GLONASS new frequencies, Galileo and Beidou, as well as dual frequency multi-constellation SPAS. So the update of the Volume 2 had to take a bit of a setback, but Volume 1 was already completed in good time. 2 other documents that have some relation is Doc 9849, the GNSS manual, which does talk about monitoring of GNSS, so that is related also a bit to testing. And Doc 9613, the PBN manual, where the whole provision of conventional radio navigation aids linked to conventional procedures actually takes on a bit of a new context, when then DME, DME, and VOR DME are being used to support PBN. One of the quiz questions about Volume 3 is, what is it about? Stated previously, officially, it's about surveillance radar system. It is a bit outdated. The surveillance panel did do a minimum update to just make sure everything is at least correct enough, but really the modern surveillance systems are covered in 9924. There's an unofficial, unpublished MLS guidance on that was thought to become Volume 3, but since MLS didn't see widespread implementation, that was never published. It is available if anybody is still wishing to implement MLS. The big distinction between 9906 Volume 5 and what is in Doc 8071 is the distinction between flight inspection and flight validation. So flight inspection is about verifying compliance of signals in space with the provisions in Annex 10, whereas flight validation is about verifying the quality of instrument flight procedures, and you will hear about this in another briefing. Nothing prevents a suitable flight inspection aircraft with a suitable flight validation crew from conducting flight validation. It's just in a different document. So this previous notion that we had of a one-stop shop for a flight inspection organization, all you ever need to read is Doc 8071. I think that one is the past, which is why we mention all these other documents. So I think it's good for flight inspection organizations to be aware of all these other documents that actually relate to it. As stated, Annex 10 is really the hard requirement, the shall statement. And the way the requirement is written, in a way, is yeah, maybe a bit old-fashioned, because it says the facilities shall be subject of periodic ground and flight tests, but it doesn't really say why. And then there's a reference to Doc 8071 that explains how it can be done. The reason why is really to ensure continued compliance to Annex 10 during the operational lifetime of the service. It is not a document for design assurance testing. That rests with the manufacturers that have to demonstrate compliance to Annex 10 requirements. So it is definitely not the same. So just by passing a flight check, that doesn't mean that the equipment is inherently safe. What it does mean is that if it's been proven to be safe by design, and you install it in an operational environment and you keep checking that, is that it continues to be safe. Some states actually make 8071 quite mandatory, sometimes through national regulation, and that is, of course, a state's good right, but it is a bit difficult to manage. When we write the shall statement in Annex 10, there's a validation method to be applied, either analysis, testing, etc. Guidance documents do not have such validation requirements. They're really a best effort from available experts, and they do not spell out every detail. Now, the whole point of guidance material is to try to be helpful. When we have to worry too much about how the words could be misunderstood, well, the tendency is to cut down those words to the minimum necessary, such that the words all of a sudden are not helpful anymore. So we do need to be able to write out in some detail what we mean without having to put every word on a golden scale, as we sometimes do in Annex 10. So whenever an interpretation of Doc 8071 is putting you down some path that is causing a very excessive effort and detailed analysis or disputes or debate, you should always remember that ICAO insists that sound engineering practice and common sense has to be applied. What counts is meeting the Annex 10 requirement, and Doc 8071 should never exclude smarter ways of meeting the same objectives. Another thing that we had maybe a few places that were sort of guidance to deviate from the annex. We, of course, took those out. You should also know that Annex 10 is quoted only for convenience. So if there's a new version in Annex 10 of the wording, they supersede that text. And then the test procedure summarizes the process and measurement aspects as described in 8071. Another common misunderstanding is in the tables. So often we hear, you know what, in this table, you didn't capture this and this little detail. Well, tables cannot do that. You know, if they could, then they would be much larger and we'd have to print much finer. And they're really there for quick and easy reference. They're not meant to describe perfectly the requirements. That is in Annex 10. It's really more meant as an aide-mémoire for you to help remember what it is all about. Similarly, A table can also not describe in full detail the test procedure. That's what the text in the main body of Doc 8071 is for. So that should be remembered. The tables are there to be helpful, but of course they cannot reflect every tiny little detail of all the various standards. The structure remains essentially intact, with the general part that has seen quite a bit of update to align with current practice, improved quality processes, new material on inspection intervals, and also new paragraph on RPAS. The VOR, the DME, and the ILS portions got the most update. NDB marker beacons as well, and we even did manage to do an update on the precision approach radar system, even though it was actually hard to find appropriate experts for that. Then there was a chapter on flight validation that is now moved to Doc 9906. It's replaced with a chapter on NAV aids supporting PBN, such as DME, DME for area navigation. 8071 also used to have documents from the ITU on FM immunity, and actually it's much easier to just get those from the ITU because you can get that from them directly, and we also had some effort on cleaning up of units. We did provide better examples of what you should do to extend flight inspection intervals, how you demonstrate stability, good correlation between ground and airborne results, evidence of high maintenance quality. And then the idea is that you set yourself a margin by which you say, okay, if I can keep from 100% deviation from the standard, that brings you to the tolerance that is Annex 10. If you can keep that to within a smaller space, that means, okay, I have a stable equipment and I still have some margin that when I exceed my own tolerances, I make them a bit tougher for myself, that, well, in the end, Annex 10 tolerance will still be respected, especially on localizer glide path alignment. So the new text on RPAS is a bit small. Starts out by saying that the basic principle is to assess compliance with Annex 10 standards using representative avionics at normal aircraft speeds, and that's where many RPAS differ. Of course, in flight inspection, aircraft is not necessarily fully representative of a fancy Boeing or Airbus aircraft. But still, having representative avionics means you can make much better judgment on operational suitability, because some high frequency noise might not be seen at all by actual aircraft in service. On the other hand, RPAS do provide an opportunity in that they can make measurements that traditional flight inspection assets cannot do, such as measure in places where you can't really hover. So for example, nicely detailed and highly precise ILS antenna diagrams that have been used. So similar to the evolution from flight inspection to flight validation, currently the movement is more towards RPAS as an asset in doing new things, additional things, better maintenance, supporting ground maintenance, for example, replacing the ILS glide path mast measurements. But of course, what RPAS can do in the future may still evolve, and for sure the end of this development is not yet done. At the end of the day, we have to remember, though, that it is about flying, and that there's tremendous benefit in having actual pilots and flight inspection engineers in the back of the aircraft. Those that actually do flight inspection, and it's not too many in the audience, if you've been on flight inspection missions, this is aerial work. This is intense work. This is not when you fly on a long distance flight and you get to relax in the en route phase of flight and don't really have much to do other than monitoring. But this is proactive, hard work, you know, flying all these different approaches. So it's an aircraft that ideally is pressurized and air conditioned, has an autopilot also to help with workload, that has a good speed range. So in terms of approach speeds, that it can do something quite similar to an Airbus A320 or a Boeing 737, but that it can also fly slow enough such that you have good measurement resolution. And then, of course, you need to have the avionics to fly in the given airspace. And one of the key challenges today is, of course, as people look towards more and more flight efficient aircraft, is to have sufficient space for the antennas with good calibration, because achieving good measurement results to a large extent depends on the antenna. And often dual set of receivers would be quite preferable. We did add material on VUR filtering that was really motivated by wind turbine development. This comes from the MLS, and specify an alignment error tolerance, a path following error, and a path following noise tolerance, and a roughness and scalloping or control motion noise tolerance. And that kind of a measurement was really supposed to help when you have issues considering compatibility of VURs with wind turbines. So I'm now in the chapter by chapter innovations. Another new thing in the DME chapter is to take into account of built-in test equipment, because quite a bit of progress has been made. The DME area navigation aspects have been moved to chapter 8 for better visibility. Then, especially with the importance of DME as an alternative aid in case GNSS is not available, two requirements have always caused a lot of debate. So one was the range measurement uncertainty, and that is often limited actually by the available equipment output of DME interrogators. So when they have an output that is on a resolution of 0.1 nautical miles, of course, you don't get down to 20 meters. The field strength uncertainty was meant to be a laboratory repeatability, as captured in one of the former footnotes, but really that didn't seem to be too helpful, and field strength measurement in DME has always caused quite a lot of debate. And so we said that actually you should make a best effort to get to 5 dB accuracy, and that is really taking a realistic look at what you can achieve in terms of AGC calibration, automatic gain calibration, in terms of antenna pattern calibration. And once you do take a realistic look at these, then of course getting the 5 dB is already quite ambitious of accuracy. On the ILS chapter, we in the annex, the definition of ILS was updated. And instead of including either a marker or a DME, it now includes a means for glide path verification check. And that is normally either a marker or a DME, but it could, of course, also be GNSS or some other means. And that has also been reflected in 8071. Another important topic is the insurance of interference-free operation when both localizers at the runway radiate, as is done more and more, and also, of course, at nearby runways. Then we did generate a new figure for displacement sensitivity and improved and clarified the text, similar to course alignment accuracy. Then finally, something which I consider a safety improvement is the removal of modulation balance flight checking. That's really not something that is needed. And of course, it puts a centered needle everywhere in the airspace. So that is not really a test that we really require anymore. And so it's really on special engineering request only. The alignment between the clarifications on the alignment tolerances and the power monitors were done. And then also 8071 had quite outdated examples of flight inspection reports, so these have been brought up to speed. Some of these examples are also in the back of this presentation. And then another big discussion in the ILS chapter was really the reference system accuracy requirements for differential GNSS. So far, the requirements were specified on an angular basis in line with the way the ILS requirements were specified. Many expressed the need to have some guidance of what that means for their reference system, for their flight inspection reference system. And so we did provide that. Others were of the opinion that it wasn't so helpful, but anyway, for those that find that it is helpful, this conversion between the angular requirements and the linear requirements that you need for differential GNSS were also inserted as a table on the ILS. A big news, this is also a point that caused quite a lot of debate, is on the course alignment, and it's similar to the measurement of reference datum height on the glide path, is that it really is much better to measure this as an average over a certain distance. And using an average over a certain distance, you get a much better measurement that is actually reflecting on the real guidance quality of the localizer course alignment. Here you see some example graphs from real inspections, and you see a bit, I think, what is by now a pretty good standard in flight inspection systems. And so those have also been introduced. I was also involved in this update here on ILS coverage requirements. You may be aware that the edges of the coverage can be raised. This was really done to enable super wide aperture localizer arrays that focus a lot of energy on the center line and therefore have a bit of a struggle to provide all the way at the far out off angle edges of the localizer coverage to provide good coverage there. This was done, for example, to reduce clearance reflections, so clearance to clearance and clearance to course interference in the signal, because some airport developments with nearby hangars and such would have struggles with that. Now, we did actually decide not to provide any detailed guidance on if you actually take advantage of this coverage reduction by raising the lower edges, how you flight inspect that. The red trajectory there would probably not be a good one. It's basically the principle of 8071. You find a suitable approach that actually does give a good solution for this. You measure some key points, and then that should be good enough. So common sense continues to be required for applying DOC 8071. We have a current discussion that is not just on periodicity. So the new guidance discusses periodicity and actually lengthening the time until you check again. But we are also discussing now a reduction of flight inspection runs, especially for the ILS. It's one of the big cost drivers, of course, but it's important for me to say that this was initially motivated more by capacity issues. So limits on nighttime operations, and then having to fly during the day when the airport is very busy was seen as very difficult to accommodate flight inspection. And so one state, the Netherlands, has initiated some work on actually trying to reduce the number of flight inspection runs. And what you can see from this model, where the navigation signal, the transmission is generated, sent to the antenna, there's a monitor function, and then here it leaves the electrical domain, gets into the RF domain, and then first you have the near field environment that you can check with ground measurement, and then it's really only the far field environment where flight measurement really plays a key role. And so the effort that we're discussing right now is to go through in detail and actually see which flight inspection runs on the ILS are essential to make sure that the far field environment gets checked effectively. And for example, something like switching from transmitter 1 to transmitter 2, if that has been good on the ground, normally in the aircraft, there should not be a difference seen. But that is, of course, an ongoing discussion. We are now getting briefings also from other states on how they reduce their flight inspection effort. If you in the audience have something to contribute, that would be welcome. And now, of course, given that capacity is not our main problem, it's really economic efficiency. So if there are innovative ways to maintain safety while reducing the effort, that will be very welcome. The PBN chapter then finally recognizes that there's a need for infrastructure assessment. So performance-based navigation is not meant to be all that sensor specific, but at the end of the day, you still need to say which sensors are good, and you still, as an air navigation service provider, still need to say which sensors qualify. We did introduce in Annex 10 the new attachment H, which is the strategy for rationalization of conventional radio nav aids and evolution towards supporting performance-based navigation. That is a strategy that matches the attachment B strategy on landing systems. And so that whole new PBN context is discussed in this somewhat short chapter there. I think that brings me to the end of my slot. I've seen questions and hands pop up. So just to conclude, we've realigned with Annex 10 Volume 1 updates. As Volume 1 updates further, we will probably get out of date again, but really our goal was to resolve or at least improve what have been long-standing issues of some debate in the flight inspection community. We've corrected many errors, but for sure some will remain in there. We do support the input from our clients or customers, as we should say, the ICAO, the flight inspection community, that gives us great feedback on how they find this document. So the Volume 1 effort is closed for now, except for this one discussion that we are having on flight inspection requirements in terms of extensions or reductions. But then, of course, feedback on Volume 2 matters remains timely and desirable. That's it for my briefing. I have a few backup slides and they will be made available later.
Thank you very much, Gary. So we reached to the first Q&A session. I'll just put the Q&As on my screen. So the first question is about phasing out of NDBs. Please confirm when are the NDBs supposed to be phased out? I think this question goes to Mona, who made the first presentation on the ICAO provisions, and I'll let Gary to see other Q&A questions, and then we will get back to the questions related to 8071. Mona, can you please answer this question about phasing out of NDBs, please?
Yes, Abbas. Thank you very much, Abbas. Thank you, Gary, for the interesting presentation. Regarding NDBs, I will first answer at regional level, Middle East level. We agreed in the Berg or Middenberg 12 meeting that all NDBs should be decommissioned by 2012. So this is the date for the Middle East. And the use of NDB should be rationalized based on need and equipage. I can say that generally, most of our states who still retain NDBs, they retain it or they keep it until the end of the life system, and then they will decommission it. We have totally of 52 NDBs in the whole Middle East region. At a global level, I would like to recall ICAO Assembly Resolution, I think 37-11, about implementing BBN. And we know that NDBs serve no role in BBN implementation, except as a means for position cross-checking and general situation awareness. And this minor role should not lead to the requirement to retain NDB facilities. And also, we know, for example, NDBs used as a non-precision approach should be withdrawn. I hope I answered the question. Over to you.
Thank you, Mona. Yes. Then let's move to the second question, which got the most number of likes in the Q&A section. Please put your questions in the Q&A, not in the chat box, to avoid losing it among the general chats. The second question is about the need for radar calibration with aircraft. I think this falls under 8071 volume 3, if I'm not mistaken. Gary may confirm. And this webinar is focused on navigation aids flight inspection. So this question is out of scope, but I wanted to read the question because the webinar that we are conducting now was supposed to be a symposium to include all types of inspections and tests. But since the pandemic hit us, so we decided to just focus on a specific issue, which is navigation aids flights inspection, and then to postpone the big symposium and cover all aspects of inspection and testing to 2021. Gary, would you like to add something to what I said?
Yeah, I'm not an expert in radar calibration. I do know that some states are still doing calibration flights, and I think it boils down to what the radar needs to stay calibrated. So it can be useful to do a flight in some cases, but there also some of my other Eurocontrol surveillance colleagues, they do a lot of tool development for radars that allows to do radar database checking of the radar. So if flying is done, that should always be done in coordination with what is done in terms of ground data analysis. That said, we do actually see that in Europe, in some places on the 1030, 1090 frequency, there's over interrogation. And Eurocontrol has actually started monitoring flights because at the end of the day, it's very good to see what's really going on with the signal in space and to get data on interrogation rates of the different radars to make sure that there isn't over interrogation, so that you don't drop aircraft from the surveillance screen. So I think that's not my area of expertise, but indeed it's an important topic, and here also aircraft can play an important role.
Thank you, Gary, and we will address this subject in the big symposium in 2021. Hopefully we will cover all aspects of flight inspection and testing. So let me move to the next question. I would answer that question, which is about the actions required by ANSP and CAA inspector in case they see the calibration or inspection date is over. If you talk about calibration by the CNS, so it's a mandate of ANSP. But if the question is about flight inspection, then what we as ICAO USAB auditors expect from Civil Aviation Authority inspectors is to keep monitoring the procedures and the implementation of Annex 10 requirement and DOC 8071 guidance regarding flight inspection during their regular Civil Aviation Authority inspections over the ANSP and over other service providers. They have to check the major issue of flight inspection of navigation aids, of flight procedures, etc. Because as Mona presented, these two are two major protocol questions of USAP program. And within ANS area, in which we have around 180, 190 protocol questions, the only questions that may lead to significant safety concern for the state are these two questions. You may know that in USAP, we will check protocol questions when ICAO comes to state and does the audit. In each area, like personal licensing, operations, air navigation, etc., we have some very critical questions that may lead not only to unsatisfactory, but also to significant safety concern for the state. These two protocol questions are the only two questions under ANS that may lead to significant safety concerns. So as CAA inspector, you are expected to keep monitoring regular and timely conducting of flight inspections and flight calibration. If you see that it's not done in a timely manner, you have to file a deficiency for the ANSP or the relevant service provider. Then you have to ask them to provide you with corrective action plan. And then after some time that is defined in your procedures, in your inspection handbook, you have to go back and check if the deficiency is resolved. And when ICAO comes and does use of audit in your country, you have to show the evidences to ICAO auditor. Another just procedural question about the presentations. We will try to put the presentations on the same web page, on the webinar web page. You will have the recording of this webinar, a copy of the presentations, and you have already the description and agenda of the webinar. Now I would move to another question. If you just give me a few seconds. Okay, there was a question about the differences between flight check, flight inspection, testing, calibration, these terms that we normally use in this area. I would ask Mona to address this question, please.
Thank you, Abbas. Actually, I will extract what's mentioned in ICAO document 8071 about the definition of testing and inspection. If you wish to refer to that, it's paragraph 1.3.3. Testing is a specific measurement or check of facility performance that form part of inspection when integrated with other tests. So this is for the test. For the inspection, it's a series of tests carried out by state authority or organization authorized by the state to establish the operational classification of the radio navigational aids. There is another definition also in ICAO document 9906, volume 5, which is about validation of instrument flight procedure. For the flight inspection, it's the operation of a suitably equipped aircraft for the purpose of calibrating ground-based navigation aids or monitoring, evaluating the performance of the GNSS. I think Gary also in his presentation, he mentioned the definition. I don't know if he would like to elaborate or add something. Thank you, Abba.
Thank you very much, Mona. We received, to be honest, a lot of very interesting questions, but actually some of them are about the upcoming presentations. So if I'm not addressing some questions, it's just I'm postponing them to receive first the relevant presentation, and we will get back to those questions. Now we are at 13 UTC. We may be able to answer one more question, and then we'll resume the rest. Yes.
If you want, I could just try to go quickly through most of the questions.
Yes, go ahead.
Okay, so the first I have here, CNS inspectors ensuring that onboard equipment is accurate and maintained accordingly. That is addressed in Chapter 1 of Doc 8071, Volume 1. And there is, of course, a calibration effort that needs to be conducted to make sure that aircraft and the antennas and the receivers all work correctly. In the International Flight Inspection Symposiums, there are a number of presentations that explain about how you ensure quality of measurements and onboard equipment. Second one, is there any rule of the content of the report given to CNS engineers by flight inspectors? There is an example report given for ILS, and you can also glean for that similar level of detail for other NAV aids. What matters there is mostly that you, of course, come to a suitable decision about whether the facility is suitable for operation or not. With the flight inspection periodicity, I think we will collect those for tomorrow. Then on the signal strength, I meant to type that. I clicked the wrong button, but this indeed is dBW per meter square is the consistent unit that is used now. So no more microvolts. The microvolts disappeared. Again, on periodicity and extension, so that will be for tomorrow. Who is responsible for providing the safety oversight on the flight inspection system, given that most inspectors are experienced on CNS and not on the FIS? Yes, of course, this needs suitably trained oversight and somebody who, but you know, if you go through the DOC 8071 guidance and you check every point that is in there, I think you already can become a quite educated inspector. So if the company is ready to give you good answers that does your flight inspection on all of these questions, then I think you quickly see whether they know what they're doing or not, I hope at least. Regulation in the DOC 8071 to say if flight check the nav aid, everything seems normal, how could we rely on the aircraft receivers themselves? Actually, one of the funny problems that people had is that some cases more modern flight inspection aircraft got more accurate and sometimes put the facility out of tolerance because they got more accurate. But again, on aircraft receivers, there are calibration processes that need to be done. You need to correctly have under control the antenna, the cables, and the receivers, and they need to be part of your calibration effort, and that is described in DOC 8071. The next one about regulation for end fires glide path, that's a very interesting system. There's no dedicated material on end fire glide path, but if you have any specific question on that, I'd be happy to take that offline. And then again, interval, then the monitoring of GPS in order to use GNSS procedures. That is not a strict requirement, but material on that is in the GNSS manual DOC 9849. And we'll talk more about that. The decrease of the 75% acceptance standard, it's mainly linked to the course alignment and path alignment. And that's, in a sense, of course, part of integrity monitoring. And of course, it can also be done for Cat 1. Whether drone flight inspection gives accurate readings as flight inspection, that depends very much on the drone. With a very sophisticated drone, I've seen cases where people suspend the measurement antenna from the drone to have a free space antenna. You have the potential to be able to do much more accurate measurements than you ever could in a flight inspection aircraft. But if it is just a cheap hobby drone with very rudimentary or imprecise sensors, then of course is more difficult to get accurate measurements out of that. But what applies is what I presented, is that at the end of the day, you need to be able to make a decision about what is operationally relevant. With dual redundant systems, I think one of the principles of why dual redundant is done is so that you actually can change the one while the other one keeps your operation going. So we distinguish between mean time between outage and mean time between failure, where of course a dual redundant system makes sure that you can have a failure of a transmitter, but not an outage of the overall system. Yeah, and the questions, they jump around a bit, and there are more. So I think we're probably at the end of the slot. So I just try to go through as much as I could in as little time as possible, and we'll sort out the others maybe then. And I can also provide that after the briefing.
Thank you, Gary. That was so efficient. So you could manage to answer many questions that were put in the Q&A section. So as you can see on the screen, again, Gary will take care of next presentation, update on DOC 8071 Volume 2 and GNSS operational issues, including GNSS interference testing. Gary, the floor remains for you. Please share your screen.
Okay, I need to just get that going. I have okay, you see the slides?
Yes, we see it.
Okay, good. So on volume 2, with the removal of flight validation, actually the GNSS volume is becoming very thin. In general, for GNSS, signal in space analysis is best done on the ground, with the receiver on the ground. And flying around really only gives you a spot check, because also the satellites in space fly around. So what you see at one moment in time is different from what you see the next moment in time. The nature of testing evolves a bit towards more engineering data analysis. And the main chapter, the biggest one in terms of size, will really be the GBAS chapter. And there's quite a bit of effort that the GBAS community has done to update the GBAS chapter now. 2 volumes will be maintained to minimize editorial efforts, also because many states have contract specifications in place. So that's even if volume 2 will be thin, ICAO will maintain 2 volumes for that. Then we also got into some discussions about what really is the boundary between flight inspection and flight validation. When you consider a landing system, it is the reference path that is used to generate the guidance signals. So then, checking path alignment, is that now really flight inspection or is it flight validation? More important in that aspect is to not forget that DOC 8071 is also about ground checking and not just flight checking. In general, the principle is that you should prepare thoroughly using whatever ground means are available, such that you don't waste time to find mistakes that you could have easily found on the ground. So there will be some improved guidance on flight path alignment verification using methods you can do on the ground. And then, of course, if at the end of the day, and this has happened operationally, you get to your flight validation and you find that the approach path doesn't actually point to the beginning of a runway, well, then you've at least figured that out using flight validation. So that should always be discovered at any point in time. So we have a revised structure. We used to have the general chapter 1 that was common between volumes 1 and volume 2. So it covers GNSS specifics only. It doesn't duplicate chapter 1 and volume 1 anymore. So that gets a lot more thin. The ABAS chapter, which was ABAS for non-precision approach, now gets extended to core constellation and ABAS, where in ABAS we are working on advanced RAIM, receiver autonomous integrity monitoring, and there'll be new material in Annex 10 on that as well that is being developed. That very much depends on the core constellations and how they perform, and they have all now signed up to publish values on both single satellite fault rates and multiple satellite fault rates for a common cause. And so much of that will be in Doc 9849, the GNS manual on performance monitoring. How much of that will really be written into 8071, we'll still have to see. Then for SBAS, really most of the testing is done by the SBAS service provider. So the SBAS service provider that typically gets regionally certified does have to provide evidence that they actually meet Annex 10 requirements. And so that burden is really on the SBAS service provider to a great extent. And there also how much will actually write apart from these words into the SBAS chapter will still need to be seen. GBAS will be the most important in terms of volume, but then there's a new chapter where the flight validation, chapter 5, gets deleted, but that becomes the new GNSS RFI measurement chapter. It builds on attachment 3, the chapter 1, which used to be where all this material was located, but because GNSS interference really is the most significant operational issue, we decided that that deserves an expansion, and I'll go through and explain to you a bit why. Another piece of related material is in the GNSS manual, which is on vulnerability mitigation, where the idea is to monitor threats, to assess risks, and then to deploy mitigation measures. That's a very basic 3-step process. And I'll get to how this can relate to flight inspection systems. So, of course, among the mitigation barriers that you can implement is first that you hope that the transmission of RFI doesn't happen in the first place. If it happens, you hope that it doesn't affect you, that your equipment can keep going. But if it does affect you, then you at least want to be able to detect and resolve. And that is really supported by threat monitoring networks, and part of the reactive role in that is where flight inspection can have a role. You see here pilot reports on GPS outages that were collected as part of the Eurocontrol voluntary ATM incident reporting system. We have a lot of coverage, not just in Europe, but also Middle East and Northern Africa. And in 2018, 2019, we would get up to 10 reports daily about GPS outages. Given a calm ionosphere and no problems with the constellation, that really means that this is most likely RFI. That went up until February 2020 and when COVID happened, but even now we still get isolated reports. And we would say that on average, it's about down to 1 report a day, which is quite significant given that traffic is down so much. What do we see? In theory, it should just be a simple outage, but sometimes things happen in the transition. Sometimes there are disagreements between the different positions that the pilot might get confused about a little bit initially. We've seen terrain warnings. We've seen, of course, requests for radar vectoring. We've seen some ground speed and wind speed wrong presentations because of some integrations. Funny things happening on aircraft clocks. And each time we check with the manufacturer. And so far, these are all possible things that can happen as part of interference to GPS equipment. And that's why many aircraft manufacturers have started to publish more detailed guidance on GNSS interference impact on avionics. And if you are operating any aircraft and do not have such guidance, do not hesitate to ask your manufacturer for such guidance. And of course, what is quite interesting in that most of the flight inspection systems today, they use GNSS for their truth reference system. And so you should also assess the vulnerability of the flight inspection to GNSS interference and the resulting operational impact. The most affected regions are Middle East to Europe, routes across the Black Sea, Caspian Sea, across the Eastern Mediterranean, so that's Malta and Cyprus and adjoining airspace, and also some of the cross-polar routes that would go over Norway and Finland. That said, it's not only a Middle Eastern issue, it's also in some Western European terminal areas at airports that have seen cases. So what we do is we collect all of these reports, and when all of a sudden there is a significant number of reports somewhere, we do get in touch with the people concerned and see what there is that we can help. The German Aerospace Research Institute, DLR, did a test flight in Cyprus airspace, north of Cyprus, of significant extent. And you see here on the left the flight that was flown, and on the right you see where GPS position was available. And that is really a very significant difference that really shouldn't be the case. Interestingly enough, this also correlates well with what the maritime sector is seeing. So I refer to this article by Catherine Dunn, who has listened around in the maritime industry. And there too, the hotspots that we see in aviation largely match those that we see in the maritime sector. What can we do? So this is extending a bit beyond the scope of flight inspection, as we can look at ADS-B track data. And when looking at track data, we can identify gaps in those tracks. So that's when the GPS position was lost, when tracking was stopped, and when it was regained. So the red line is when GPS was out. From that, you can add up all the quality indicator of the ADS-B, and really the first priority of what you want to do with that information is to manage the impact on the operational traffic. So ADS-B reports give air traffic control a bit of a picture of what is really going on. But in terms of doing something about the interference, what we can generate are RFI source heat maps that uses a power difference of arrival approach. And so we see that this is to the south of Cyprus, so Lebanon, and then over international open waters, where we see likely locations of interference sources. And so here you see how a measurement from aircraft flying in the airspace can already provide an approximate location of where this interference is located. It is quite approximate, so actually having a flight inspection measurement could help quite a bit. Because of all of these issues, ICAO issued a state letter last August and said, please make use of the guidance in the GNSS manual on interference mitigation. All the way at the end is a checklist that is meant to help you see whether things in your state are in place so that you can do something about RFI. And that includes measurements capabilities for all potentially required monitoring tasks. In some cases, may also make sense to do ground-based monitoring around airports. And then, of course, capabilities to detect, locate, and identify interference sources. There, it is very useful to have an aircraft capability. And then, of course, to have people trained to actually recognize and deal with such events. So those are some of the recommendations that are being put forth with the state letter. What I've just showed you with the pilot reports and the ADS-B analysis, the big advantage is that you know there's operational impact. The disadvantage is that you don't have a solid proof of interference. And such a proof of interference would be very desirable to have suitable radio regulatory actions. On the ground, you will often not see the interference impacting the aircraft at altitude, but you can record continuously, while in the air, you can't stay up in the air forever. But if you can actually get an approximate location on the ground, you can help the ground resources to try and do something about that. And so whatever you can do to increase your interference detection capabilities, you should actually consider. That can start from just a basic measurement quality GNSS receiver that can have RFI detection features and others, to actually capturing the RF signal, to actually see the spectrum band where satellite navigation systems are broadcasting. And the best, of course, would be to have a direction finding capability. We had a project in 2016, where we looked at using military technology. So this is a controlled radiation pattern antenna that uses a multi-element antenna to see whether we could figure out, so the red dot here on this graph would indicate a potential interference source location. So if we could actually use a GNSS array to help geolocate. You can consider that paper. That's, I guess, more of a high-end possibility, but many other possibilities are possible as well. Solutions are possible as well. Aviation operations really rely on GNSS with PBN and ADS-B. That was true for capacity, as we've had troubles more last year, but also for reduced environmental impact. Inertial navigation systems, DMEs, ILSs, but also VOR DMEs are complementary to that, and they're the main alternative navigation capabilities we have today. So keep them going, as the previous presentation. And then the most important operational issue today is interference. And so if you have an airborne spectrum measurement available, that really is hard to beat. You can consider recording during a ferry flight. You can consider also other aerial work aircraft. One example is what was done in Switzerland with helicopter emergency medical service recording. So those are just a quick access recorder installed in a helicopter fleet that gave sort of a tapestry of the whole interference landscape. And just even a very basic GNSS receiver can give you much more detail than a pilot report ever could. The moment you can carry the noise ratio of individual satellites, you know a lot more already about the interference. Near conflict zones, if it's about making political noise, having independent measurement verification can be very valuable. So coordination amongst different flight inspection providers can be very useful. And we are also working on future aviation receivers that use multi-constellation to actually detect and downlink interference information in the future. There's a number of projects ongoing to help establish best practice. We need to continue to exchange experience on that, and for sure some of the presentations tomorrow will probably address some of that. The idea, though, is that we don't start building a whole monitoring system on the ground that covers the Earth with monitoring systems on the ground, because the whole benefit of GNSS was that it's a space-based navigation system. So whatever we do, it needs to be balanced and it needs to be complementary in a reasonable and sensible way. That's it from my side. I thank some of my colleagues here that have provided some of the data in this presentation, and I'd be open for questions.
Thank you very much, Gary, for the very interesting presentation. Before we move to the last presentation of today, and then in the end, we will have a Q&A session again. I would like to invite Mona if she has any additional remarks on the GNSS vulnerability and relevant issues regarding the presentation of Gary. Mona?
Thank you, Abbas and Gary, and thank you for the opportunity. Actually, as Gary mentioned in his presentation, our region, Middle East region, suffer a lot from GNSS interference since more than 2-3 years. And I would like just to highlight to all aviation stakeholders in the Middle East that we already developed a RASC safety advisory on GNSS vulnerabilities, and this safety advisory was developed based on GNSS manual 9849. In this safety advisory, you can find information about interference sources, intentional and unintentional, risk management, and strategies also to reduce the likelihood and the impact, as mentioned also by Gary, the reactive and the preventive measures. And also a reporting procedure that was developed in coordination with IATA Middle East. So I would like to invite everyone to implement the preventive and reactive measures and strategies as mentioned in the GNSS manual and in the safety advisory, and also to follow the reporting procedure in that safety advisory. Thank you very much, Abbas.
Thank you, Mona. Very important remarks. So let us move first and take the last presentation, and then we will have a Q&A session to address possible questions. The last presentation of today will be made by Mr. Fabrizio Marasic. He is a flight crew training manager from INAV, Italy. And the presentation is about update on Doc 9906, Volume 5. Fabrizio, the floor is yours.
Thank you very much,
Please
Abbas.
share your screen also.
Yes. Let's see if it goes. Okay, it should work right now.
Yes.
Thank you, Abbas, for the introduction. Thanks, everybody, for participating to the webinar. Good morning, good afternoon, good evening. I hope that in your state you are enjoying a beautiful sunny day as I am enjoying here in Italy, even if it is a little bit cold. Why discussing about flight validation? Flight validation is relatively new in ICAO literature. And in the, let me call them the old days, which is pre-2012, when 9906 Volume 5 was published, basically validation was included with inspection, and it was more or less the same things. There were not many formalized steps to validate a procedure in most of the states. It was considered to be a normal activity that you perform when you were commissioning VOR, also to check the VOR procedure, or when commission an ILS to check also the ILS procedure. Was not really formalized. But we found that there were a need to a formalized process because we were entering into a new era, a different one, where the trajectories were made by coordinates in space, not directly related to antennas on the ground transmitting electromagnetic signals. And so we saw the need to do quality assurance on the trajectory that were designed by our procedure designer. Of course, in theory, if you design something according to the PANSOPs, the Doc 8168 Volume 2, it should be safe by design. If it is a PBN procedure, according to 19613 RNPAR 9905, then it should be safe by design. But now we are talking about databases and computers. So there is a need to check that the design matches with the real world environment, obstacles, airspace, interactions, lighting, ground lighting system of the airports, and all these kind of things, because we were implementing new procedures. Okay, so don't look at the left side of the slide. My qualifications are not important here, but look at the right side. You see those three logos. You see ICAO, ICASC, and IFPDAVA. Why we have this logo? Of course, ICAO is the umbrella under which all the regulations for civil aviation are made. And the other two international committees, ICASC and IFPDAVA, contributes in flight inspection and in flight validation. This is really important to have support from international organizations because we need to remain in contact with the real world. This is the only way to have rules and regulations that are actually usable and makes sense, are efficient, safe, and economical at the same time. Okay, so you see on the right side that the wheel is turning. We are updating. Of course, this is not going anywhere. It will keep updating forever because every document needs to be updated from time to time to be in line with the expectation of our customers, which are the airspace users, and ultimately with the safety of the passengers that are the one that will use the air transportation system. So what we do to remain in touch with the reality and update the documents as needed. First of all, we have ICAO job cards. That means that ICAO decide in terms of policy that we have to implement something for the benefit of everyone. Then we have inter-panel coordinations. Between different ICAO panels lies the responsibility of different things, and those things are interconnected and are strictly interconnected when you put together a GNSS procedure design, flight inspection, and any different domains that is not under the same ICAO panel, of course. Then we have a field experience. As I said when I was introducing the first slide and the second one, it is important to remain connected with the reality. And then we have the internal instrument flight procedure panel brainstorming. So this is an example of the job card. This is a job card IFP 19. Of course, this is an ongoing process. Those processes have been slowed down, not consistently, but in some way due to the pandemic, of course. We have basically weekly meetings online with the rest of the IFP members to try to keep up with the work at hand, because it is important to continue our work, because sooner or later, hopefully sooner, everything will return back to normal and we will need to have those rules implemented. Inter-panel coordination. As I say, this is one of the most important things that in the past was not working perfectly. Now the system is well lubricated, is a gear that is being very well lubricated, and especially for the connections that we have between flight inspection and flight validation. And I would like to remember everybody that my experience comes mainly from flight inspection after 20 years in the flight inspection and validation department, but this became and validation department after 2012 with the implementation of 9906. It is really important to keep the two domains in contact because the two things are correlated in some way. You cannot do inspection of a conventional, you cannot do validation of a conventional procedure if you don't have assurance that the flight inspection of the supporting NAV infrastructure has been done. So the two worlds will be forever interconnected. Even though I have to say that my vision for the future is that we will see over the years less demand for flight inspection and an increased demand for flight validation. This is a normal evolution of the situation because, of course, we are facing cost-saving struggle everywhere, and we are trying to reduce costly to install and to maintain conventional NAVs. Muna explained us about the plan to reduce the number of NDBs. Every state, I think, has programmed to reduce conventional NAVs, NDBs, VOR. Maybe we will keep in the future just a network of a DME for DME navigation on top of GNSS, of course. So it is important to remain, to maintain this contact between flight inspection and flight validation for many years to come. Field experience. Field experience is, to me, one of the most important things, because as I said, remaining connected with the reality, it's of paramount importance. We have seen many times in the past rules written in a way that were difficult to implement. Now it is way better. I think that all the rules, as Gary has explained regarding 8071 and the 9906 volume 5, 6, and the other volumes in the 9906 series are really usable. I mean, it's something that can be used easily and it is understandable by everybody. You don't need to be a lawyer to understand and implement what it is written in those documents. So what we have updated so far, because this is all about. The flight inspection and validation were required, and now we are talking about what we have done to update 9906, especially volume 5. So there are these 2 points coming from field experience. The first one is an allowance to allow states to permit cross validation. That means that if you are a fixed wing pilot, the state can approve you to do flight validation of instrument procedures. And of course, it may happen also the opposite case. If you are an helicopter pilot, you can provide validation services for fixed wing procedure. Why we had this necessity? This is a practical solution to a practical problem, because when the rule was initially written, and you can find references to this in volume 5 and volume 6 of 9906, the idea was to keep the two words completely separated: rotary wings on one side, fixed wing on the other side. But then we started to look into the data, and the data shows that in a career of a commercial pilot that has all the requirement, more than 1,500 hours, IFR, and so on and so forth, probably 95 to 97% of the total flight time has been flying IFR. If you take an helicopter pilot with the same experience, probably the percentages are reversed. Most of the flight time is flown VFR. So that means that in the helicopter pilot's domain, I don't want to be misunderstood here, I don't want to generalize, but this is on average, the experience in an IFR flight is limited or non-existent. So we found that in many states, there was a practical difficulty in finding properly qualified pilots to validate helicopters procedures. So that's the reason why this amendment has been approved, the one that you see with the number 1. Then we have number 2. There are some better explanation of operational aspects. What is a flight validation aircraft, certification requirement. There is a more strong statement that says that you are not allowed to do flight validation during commercial service, I mean, with passenger during a revenue flight, because we have in the past some demands from operators to do this kind of activities, which is clearly something that should not happen. Those are already approved amendments that have not been published so far due to the pandemic and the fact that for the next foreseeable months the process will be a little bit slower than usual. The AFP usually is very productive, but during the pandemic it is not so easy to keep up with all the necessities. Then we have done some brainstorming within the IFP, collecting all the information to do some update to the flow charts and to the process. We want to keep all the items and the tasks, but probably the logic of the flow chart and some of the tables that we have at the beginning in 1.2 of the 9906 volume 5 will be a little bit rearranged. Then we will have a fine-tuning of the various steps of the process after this revision of the flow chart, and a revision also of the chapter about collected parameters, because we need to implement a better understanding of the fact that conventional procedures are still in existence. And if you look into those chapters, it looks like we are talking only about the GNSS procedure, but this is not the case. Probably when we originated the document, we had other intentions, but at the end we saw that this is the interpretation, and we needed to add some more detailed explanation to that. And then we have other ideas on the table that at the moment are not so mature to be presented. to this audience. So what is the way forward? And we are close to the end of this presentation. So the idea is that we had was to prepare an umbrella paper, which is a big paper that encompasses all the needs that we have foreseen for the maintenance of the 9906 series of documents, and not only, and also for the revision of certain chapters of the PAN-SOPs. Why having this kind of umbrella paper? Because we want to monitor continuously the real world needs. We want to integrate the changes with other ICAO documents as needed, but more importantly, and that's the entire concept under the umbrella paper, we want to have all the changes that we need to implement in one paper, even if it is subdivided into different documents and different chapters, for consistency, because over the years, the number of documents that ICAO has published have proliferated, and maintaining consistency across all the documents has become one of the major efforts of everybody working in an ICAO panel. So this is really important to maintain consistencies. This is all. Thank you very much. Bas, back to you for the Q&A.
Thank you very much, Fabrizio, for the interesting presentation. Before we get into the Q&A, I would just announce that tomorrow, please rejoin us for the second day that we will address the periodicity of flight inspections, the issues caused by the pandemic, and also the ICAO QRG, Quick Reference Guide, on this matter, as well as experiences by some states, France, technologies used in flight inspection, and also experiences from some countries in the mid-region, Jordan, Oman, and Iran, with regard to the issues caused by the pandemic and also the regular flight inspection practices. So I will invite you to join us again tomorrow. And then from now until 2 p.m. UTC, we will have 16 minutes to address some questions. I will first start with 2 questions about which is relevant to the area of Mona. And in the meantime, I ask Fabrizio and Gary to go through the rest of the questions, and then I will give the floor to Fabrizio and Gary to address those relevant questions related to their presentations. We will skip questions on the periodicity that will be addressed tomorrow. Mona, first question is about spoofing event reports. Have you had any of the spoofing reports? So this is your question, Mona.
Thank you, Abbas. I think I cannot say it's my area since we have Gary. He's the author or the main author of the GNSS manual. But I would like to answer it about the report received or incident report received in the Middle East. Before I speak about the report, I would like just to speak about the definition of spoofing for those who are not aware of it. Spoofing is broadcasting a false signal or GNSS-like signal with the intention to provide false direction or false information guidance to the aircraft. In the Middle East, all reports we received were about GNSS outage. So we didn't receive any report about GNSS spoofing. Also, as per the ICAO GNSS manual 9849, GNSS spoofing is very unlikely to happen because the aircraft is moving very fast, and it's very difficult to, let's say, imitate or to generate GNSS-like signal, and that can provide information to aircraft, because we have also other sensors on board the aircraft can do the integrity check, like, for example, the ABAS, RAMs, or AIMS. So that's all from my side, and I think Gary can elaborate more on these issues. Thank you, Abbas.
Yes, thank you, Mona. So we need to distinguish between simple spoofing versus complex spoofing, and we also need to distinguish between spoofing that is actually targeted at an aircraft versus spoofing that is not. In my slides, there will be also a slide that has some links to an article that I wrote about spoofing that you can consider. We have one case of confirmed spoofing some years ago in Hanover, which was a badly adjusted repeater. This is a signal repeater that is, for example, used inside a fire station hangar to make sure that the fire trucks have quick initialization of GPS. The aircraft on approach switched to that static position on top of the fire station hangar. And this was very obviously recognized by the pilots because they knew they were in flight. Apart from that, we have cases that could look like they could be spoofing. So far, we have always verified that they are possible equipment anomalies, especially with some things that we have seen on ADS-B data. So we have seen a few things that could look like they are spoofing, but without an RF measurement, it's actually very difficult to confirm. So we have no case that we are aware of that is a confirmed case of spoofing. Now, spoofing is becoming, unfortunately, more easy. It's a digital gadgetry. But to actually target an air transport category aircraft is quite a sophisticated undertaking. And one of the big advantages that they have if they are equipped with inertial navigation systems is that the moment signal anomalies are present on GNSS, normally quite quickly they change to inertial navigation, and that's where redundant sensor capabilities really help save the day. But it is something that we are watching very closely. One of the reasons you, of course, don't hear much about it is because that's not something that we want to see in the press. But there are expert groups working on this topic and trying to update risk assessment and trying to develop appropriate strategies to also mitigate risks related to GNSS spoofing as much as possible.
Thank you, Gary and Mona, both of you, for the answer. I'm trying to distribute the questions between the panels. Actually, Mona was right when she said that we have really a strong team. We have pilot, flight inspector, CNS engineer, CAA inspector, etc. in our panel, so it's difficult to choose who to answer. There is another question about RFI on GPS affect the new satellite-based ADS-B in the same way as the ground-based ADS-B? Mona and Gary, and then I'll leave Gary to look after other relevant questions, and Fabrizio as well. Mona first, please.
Thank you, Abbas. Actually, when we talk about ADS-B, whether it's a ground-based ADS-B or a space-based ADS-B, as shown in Gary's presentation, the problem or the interference affect the transmitter. So whether state use space-based or ground-based ADS-B, it's the same transmitter on board the aircraft. So if it's affected, it will affect both. That's what I think, but I don't know if Gary has more elaboration or different answer. Over to you, Gary.
Yeah, so we are having talks with Aireon that provides space-based ADS-B. Your answer, Muna, is fully correct in that the GNSS receiver gives out the position and he hands it over to the ADS-B avionics. And if the GPS receiver is jammed, then of course it will not do that and therefore not produce a position report. Sometimes there can also be a few anomalies in that process, but then it's really only a reception issue on the 1090 link. So if there's interference on 1090, that's when you will see, for example, cases where If it's local on ground, then your ground-based ADSB reference station will not be able to receive that report if there's interference on 1090, while maybe your space-based ADSB might still see it. So that's an issue on the 1090 frequency and not on the 1575 megahertz frequency.
Thank you very much, Gary. Can you continue to see other questions? And we skip those questions about the periodicity and we leave it to tomorrow.
There is one about
yes, go ahead,
flight
Fabrizio.
validation that I can answer.
Yes,
and the question is any scheduled flight allowed to conduct flight validation without referring to a specific flight validation airplane? As I said during the presentation, validation flights during revenue services are not allowed. I mean, there will be a clear statement in the next issue of the 9906 volume 5. As I said, that this update has been already approved, so it is a done deal. It's just a matter of publishing it. But I have to say that there are many possibilities of using an aircraft to do validation. At one point in the process, the stakeholders will have to decide if it is the case to go ahead with a simulator evaluation, a flight evaluation, meaning a real aircraft flying, or both, or nothing, depending on certain conditions. So if a specific operators wants to validate a specific procedure which is tailored for them, they can use one of their aircraft, provided they install certain devices to collect the parameters that are required to be collected to provide a report at the end of the activity, and do a flight if they deem necessary to do so, but not during revenue services. That's the whole point. So you can use any aircraft that is suitable for that kind of procedure. Of course, the aircraft must be equipped in a way that the normal avionic of the aircraft is able to follow the procedure.
Thank you, Fabrizio. Gary, any other question that you would like to address?
I've been busy typing away answers. So
yeah, by the way, we will provide the questions typed in the Q&A section together with the written answers, and we'll upload the question and answers on the web page as well. So don't worry if few questions could not be answered due to time limitation. Go ahead, Gary.
Yeah, okay. So I see one from Emanuel Sabiti. I haven't seen any ATM incidents regarding GNSS outages in Africa. Does this mean there's limited coverage of satellite in Africa? No. It just means that our Eurocontrol reporting system has limited coverage in Africa. As Eurocontrol, we are responsible for the European network of airspace, which of course means we closely coordinate with our neighbors, Africa, Middle East, North Atlantic, to coordinate traffic. But of course, our visibility is limited there. So while we think that satellite coverage of these global navigation systems is very good, when it comes to collecting ATM incident information, that should be done locally. Does the interference analysis, I've seen one, does the interference analysis need to be done by a specialist? The questions, they jump around. So, but one question was whether the interference analysis should be done by a specialist or if a normal flight inspector can do this. The advantage of a flight inspection aircraft is that you have a measurement capability right there, and of course it's very nice if the flight inspection aircraft can actually make those measurements, provided it's suitably trained. There are a few details to be respected. Settings in the spectrum analyzer or whatever device you use to collect spectrum measurements. The most important thing is that the person is suitably trained to make the right measurement. That can be done by a flight inspector, but can also be done by other people. What is most important is that it's done as efficiently as possible. So certainly if resources can be combined, that would be ideal.
Abbas, Fabrizio here. There is one that I may answer if we still have a couple of minutes to spare.
Yes, please, Fabrizio, go ahead.
It's the one about flight validation of ADS-B. The question is validation of ADS-B. Our flight inspection system can log in the data from FMS transponder, but we cannot read information about that of baro altimeters. It is important for flight validation of ADS-B. It might be important. The point is that it depends on how you collect the data, what kind of ADS-B transponder are you using. Usually for flight inspection purposes, because in this case, it's you are validating maybe the ADS-B as a whole, but it is also a matter of calibration. So it's a flight inspection under this circumstance. It depends on the type of transponder that you have. Usually we use a calibrated transponder in which we can modulate power according to the requirements to see if we can receive the data in the proper way in the coverage that is required for the ground installation. So it depends on the type of the system that you are using and how the system collects the data, and if the transponder is able to be put in low power mode or not. And there is also one thing that I want to add to conclude my previous answer about the flight validation aircraft. Of course, can be used a generic aircraft which is equipped to collect the data to do flight validation. Not if you design a procedure that is meant to be used by Boeing 737 or Airbus A320, this does not mean that you cannot use I don't know, a Bombardier Challenger as a flight validation aircraft, as long as you can simulate the same characteristics of inertia and speed of the other aircraft that are supposed to use the same procedure, and provided that you have on board the recording devices that you need to collect the data required to produce the report at the end. Thank you.
Thank you, Fabrizio. We are almost at the end of the webinar, but if you, Gary, Mona, Fabrizio, if you see any other important question, we can still extend for a couple of minutes in order not to miss the important questions, but I think we addressed almost the majority of them. Gary, Fabrizio, Mona, do you have any other question to answer?
Okay, Gary, go ahead, because I have one.
Yeah,
but,
I have no particular ones, and we'll make an effort to answer all the questions that are there. And of course, you can also contact me afterwards if there's any specific details that you would like to clarify. Thanks all for listening.
Yeah,
and
there is yes, Abbas, thank you. There is one. It's just an highlight. There is a question about Adnan Malik. Can you provide an EASA regulation about flight calibration? At present, we don't have any EASA regulations about flight inspection or flight validation, but I know that EASA is working on that, because they found out that flight inspection and validation are activities that they deem necessary to regulate. So probably we will have the first draft regulations, according to my sources, by 2022. I'm not 100% sure that given the pandemic situation, this will actually happen. But this is the plan that EASA has on flight inspection and flight validation. So we will have regulations for providers and for flight validation pilots and for inspectors. This is what I know so far, and this is the information that I can provide. Thank you very much, Abbas.
Yeah,
Thank you,
what
Fabrizio.
I can complement there is, of course, that they need already to meet all the EASA regulations just for being a basic air operator.
Okay, thanks. If there is no other issue to be addressed today, I tend to get into the conclusion and ending of this webinar. And thank you very much, all of you, for your participation, and the panelists and speakers for their presentations. We will continue tomorrow at 12 UTC, so we look forward to see you again tomorrow on the second day of the webinar. Thank you very much, and have a nice day.
And you guys will capture all the Q&A and send that to us separately?
Yes, the Q&A questions will be captured, and we will prepare a Q&A document with you guys. The panelists and speakers will be assigned to answer relevant questions, and then we will share it with the participants through the web page of the webinar.
Excellent. Thank you.
Thank you all. Have a nice day.
Thank you all. Have a good day.
Thank you very much.
Thank you very much. Have a good day. Bye-bye.
Thank you very much. Have a good day. Bye-bye.